Hey guys, today I will be going over question 1 of the AP Physics 1 2024 free response questions. So, first off, we have a block of mass m is released from rest at point A, a height 6r above the horizontal. After being released, the block slides down a track as shown. When released from point A, the block does not lose contact with the track at any point. Points B and C are located at the highest points of their respective circular loops, both of radius r, and all frictional forces are negligible. Okay, from what I see, this would be very almost entirely related to energy. Diagram A shows an energy bar chart that represents the gravitational potential energy UG of the block Earth system and kinetic energy K of the block at point A when the block is released from rest at height 6r. Draw shaded regions in diagram B that represent the gravitational potential energy UG and kinetic energy K of the block Earth system when the block is located at point B, a height 2r above the horizontal. So, as we can see, the total UG would be defined as UG equals mgh. Let me change the brightness a bit. Okay. UG equals mgh. So at the start, when the block is released from rest, as we can see, the kinetic energy is zero because the initial velocity is zero. However, in diagram B, we know that there has some speed, there is some kinetic energy, and there is some potential energy. Well, how do we do this? Well, we can use the conservation of energy. The question asks for the block Earth system. No net external work or force is being acted on the block and the Earth. So from that, we know that total mechanical energy is conserved. So this, both of these energies would sum up to this. So UG, we can use the same formula, mgh. So this time, UG would be equal to mg times 2r, because if r is a radius of 1, then the diameter or the height would be r plus r, which is 2r. Now, comparing to this one, at point A, the gravitational potential energy would be equal to mg6r. So the gravitational potential energy at point A would be 3 times as much as the gravitational energy at point B. 6 divided by 2 equals 3. So this bar should show 3 times as much more energy as this bar. So how many bars does this have? 1, 2, 3, 4, 5, 6. So if this is 6, 6 divided by 3 is 2. So the potential gravitational energy of the block at point B should be equal to 2 bars. Now, the rest of the energy will be converted to kinetic energy. As I said about the conservation of energy, the total mechanical energy will stay the same. So if UG increases by a factor, then K increases by the same factor. So since UG decreased by a factor of 4, then K should increase by a factor of 4. And it should look something like this. Starting with the conservation of energy, derive an expression for the speed of the block at point B. Express your answers in terms of r and physical constants as appropriate. Begin your derivation by writing a fundamental physics principle or an equation from the reference book. So this is a very common thing that is tested on the AP exam. It was so first of all, the question states and gives you a big hint, starting with the conservation of energy. What is the conservation of energy? The conservation of energy states that the initial total mechanical energy is always equal to the final mechanical energy. So, what consists of the initial total mechanical energy? Well, as we can see, if it's a block Earth system, the total mechanical energy will be the gravitational potential energy plus the kinetic potential energy. So we write that for both of them and we expand. However, we can note that the kinetic energy initially is zero because initially the block is not moving. So what we're left with is the gravitational potential energy initial, which is mgh, which is m times g times 6r, equals final, the like I said, the gravitational potential energy would be mg2r plus k initial. Sorry, k final. So k final would be 1 over 2 mv squared. That's given for every single kinetic energy. 1 over 2 mv squared. And now we want to solve for v. So we just isolate for v now. mg r times 6 minus 2 equals 1 over 2 mv squared. I might change this to an big M. We can cancel out the M. This becomes a 4 multiplied by 2 is 8. 8gr equals v squared. So v would ultimately be equal to root 8gr. And that would be your final answer. Okay, question C. On the following dot that represents the block, draw and label the forces that are exerted on the block the instant the block slides through point C. Okay, so at point C, what we know is that there's always gravity, and the only other force is the force that counteracts the gravity force, which is the normal force. So because there's no net work or force applied to here, it might be moving in this direction, but a force is not applied to this direction. So the only forces are gravity and the normal force. Now, you might be wondering, which has the bigger magnitude? Well, we know that since the block stays at the top and keeps moving at point C, that means that the normal force is bigger because the force that counteracts and is perpendicular to the surface should be bigger. So something like that. And we'll just do that here. Fg and then Fn. Okay. A student claims that 4r is the minimum height of point A, such that the block can slide through point C without losing contact with the track after the block is released from rest. Briefly explain why this claim is incorrect. So, at point A, if this is 4r, if that is 4r, then the total mechanical energy would still be only the gravitational energy, and it would now be m times g times 4r. Now, what we realize is that at point C, the height of this is also 4r because this part is 2r, this is r, and this is another r. So the total height of this would be 4r. So at point C, if this happens, then at point C, the total mechanical energy would also be equal to mg4r. There would be no kinetic energy at point C. And let me explain that. Um, the the gravitational potential energy is 4mg4r here. And if the gravitational potential energy is mg4r here, that means that there is no kinetic energy. It stays as gravitational potential energy, which means no velocity. So, no velocity. And if there's no velocity, then ultimately it's not moving in a circle anymore. It's not going on the track. It's just going to drop, and it's just going to stop at the top, and it's just going to drop. No velocity, so it is going to drop. Now, make sure that you be more concise and clearer than what I am explaining. I'm just doing this to show you and write down my thoughts, but you have to write down more and elaborate more. And that would be all for question one.